Welcome to the Unit 6.1 Synopsis video. This video gives a big picture look at the unit, introducing the unit challenge scenario, the flow of lessons, and the background content required. This unit is designed as the first unit in the 6th grade MyStar curriculum. Unit 6.1 is comprised of 9 lessons, including the opening lesson and closing lesson, requiring a minimum of 21 50-minute class periods. The semester unifying cross-cutting concepts are systems and system models. If students are unfamiliar with systems and system models, use the off-the-shelf lesson UCC Systems and System Models to introduce your students to the cross-cutting concept. This off-the-shelf lesson is found on the MyStar web portal under 6th grade units. In Unit 6.1, titled Water on the Move, students explore the water cycle and how humans can influence the movement of water on Earth. Students discover the pathways water may take through the water cycle and how changes in thermal energy impacts the motion and spacing of water molecules, resulting in phase changes that drive the movement of water through this cycle. Students will use this knowledge to address a 21st century challenge that asks them to choose a suitable plan for mitigating the impact a community is having on their water system. The unit challenge question is, how does human development affect how water moves through our community? Let's take a closer look at the unit challenge. As presented to students in the unit challenge scenario, the local community is concerned about river flooding and loss of habitat. Not far from your school, there is a piece of land with a small stream flowing between a concrete parking lot and an old field. This land is no longer used, and the owner is worried the lot might be part of the water problem. If the planning committee can show how the land can be used to improve the environmental, economic, and social conditions of the community, the landowner will donate the land to the community. The planning committee wants students to evaluate proposed plans to revamp the unused land near the school. Before students can advise on which plans will be appropriate, they must explain why the flooding happens more often now than in the past, by investigating the multiple pathways water can take when moving through the water cycle. Throughout each lesson, students will apply their learning to this challenge and will ultimately make recommendations for how to repurpose the lot in order to reduce flooding and benefit the community. There are a total of 16 different proposed development options. It is important to note a key point about the unit challenge. Students are not being asked to design a solution. They are asked to define the criteria and constraints for a successful solution, and then unit challenge teams evaluate how well one of the proposed solutions meet the criteria and constraints, with each team evaluating a different proposal. You may choose to mention this in Lesson 1 after the unit challenge scenario is introduced to prevent any misconceptions about what is being asked of the class. In the lesson closer, students get the opportunity to recommend a solution they think is best, but the focus of instruction is what constitutes well-defined criteria and constraints. One of the tools that students will use throughout the unit are models to describe their observations and develop their ideas. These models will ultimately help students address the unit challenge scenario and to answer the unit challenge question. There are 2 models of the lot that the students will be using. The forested lot model represents what the lot looked like in the past, prior to being logged, while the present-day lot model is a representation of the contemporary conditions. For a given lesson, you should work through the forested lot model as a class, adding the content from that lesson. For example, in Lesson 2, the class would work through adding gravity-driven water movement to the forested lot model. After this point, students should split into their unit challenge teams and relate the scientific information they learned to their present-day lot models. They may use the forested lot model as a guide, but be sure to mention that they should not merely transpose what is on the forested lot model to the present-day lot model, because certain variables will differ depending on the surface material. For example, infiltration will be lower on the parking lot compared to the forest. Here we can see an exemplar of the present-day lot model progression. This model is introduced in Lesson 2, where students add water movement resulting from gravity. In its final form, after Lesson 6, we can see how the model has grown to encompass many of the processes in the water cycle, as well as how there are inputs and outputs to the system. Adding to and revising this model throughout the unit will help students answer questions and address the unit challenge. We are now going to focus our attention on brief summaries of the lessons that compose Unit 6.1. In Lesson 1, students consider the locations of water on a number of landscapes as well as in their communities through a water scavenger hunt. It is during the Connect Your Idea phase that students are introduced to the unit challenge scenario and unit challenge question. For Lesson 2, students use models to explore how gravity influences the movement of water through processes, including infiltration and precipitation. During Lesson 3, students learn about the ways in which we cannot see water move as a result of energy from the sun through processes such as evaporation and transpiration. It is at the end of this lesson where students complete their first three-dimensional MyStar embedded assessment. In Lesson 4, students uncover why the different states of water behave a particular way by using the PhET simulation model developed by the University of Colorado Boulder. The PhET simulation is used to explore the particle movement of molecules for solid, liquid, and gas phases. Students describe how the different states of matter allow water to move in different ways during different parts of the water cycle. For Lesson 5, students revisit the PhET simulation model, but this time explore the influence that changes in thermal energy have on the state of water. Students identify how changes in the thermal energy in the system causes water to change state. During the Check Your Progress phase, students complete a second MyStar embedded assessment. During Lesson 6, students explore how water moves on a global scale by using an adaptation of Project WET's Incredible Journey game as a model. Through this exploration, students learn that although water moves at different rates through the Earth's water reservoirs, it continuously cycles and does not stop. Students also add additional anthropogenic scenarios to the game and explain how humans might influence the movement of water between reservoirs. In Lesson 7, students learn how well-defined criteria and constraints are important to choosing a successful solution to a problem. They apply this knowledge to the unit challenge scenario by working in their teams to refine the criteria and constraints provided by the unit challenge. In Lesson 8, unit challenge teams evaluate proposed solutions for the unit challenge scenario. During the unit closer, the class revisits the unit bubble map, and students reflect on changes in their understanding. Each student challenge team evaluates how their proposed development option meets or fails to meet the needs and wants of the community while improving the watershed of the undeveloped lot. For the unit's culminating experience, student teams present their findings of their proposed development option to the class. Through a consensus discussion, the class recommends a solution that best addresses the unit challenge scenario. Finally, students individually take a MyStar three-dimensional post-assessment which completes the unit.